Hey, how is everyone doing? So we know the ideal gas law, PV is equal to nRT. Today we're going to be looking at what happened when these variables start to shift and change and how would other variables change within. So let's take a look at the formula here. Of course, PV equals to nRT. Okay? If you were to isolate all of the variable on one side, you would have, of course, PV over nRT. Okay, let's just say this is all initial numbers and there's some sort of final numbers because, as the title states in this lesson, changes. So there's some sort of change, let's say in pressure, there's some sort of change within, let's say, volume or quantity in moles, temperature. There's the other variable will probably change too. So let's call the final P2, V2, N2. Now don't be ridiculous and think that what about R2? Yeah, R is ideal constant. That's not a changing variable, I hope you know. But since it's not mathematically, it really doesn't matter, does it? Of course not. So goodbye, R. Nice seeing ya, but then you are no longer required. So the formula here, of course, is that you have P1V1 over N1T1 is equal to P2V2 over N2T2. Okay. Now, depending on the nature of the question, okay, when you have a variable that remain constant, you're just going to make this mathematically easier. Like, for example, if the question says, hey, pressure remain constant, that means this number and this number is going to be the same. If they're the same, be my guest, cross them out, and your formula here is going to be a lot easier. Okay? Again, if the amount, if you didn't add any moles or take away any moles, and the temperature remain constant, this whole thing is gone, right? Because, they're just going to cancel out. Or in this case, when you bring them to the other side, it'll equal to 1. So it makes this equation a whole lot easier to look at, I guess. But this is not a big, this is not a big deal. The only thing here, of course, is knowing how to use these equations and really, reading the question carefully. Because you don't want to mistake P1 with P2, do you? No, of course not. So let's take a look at some of these questions. So let's do this one. Let's do this one. I like this one. So, as I said, these are the things that you're gonna have to read very carefully. I have 135 milliliter of hydrogen gas at 1.5 atmosphere, and it's compressed to a pressure that is 7.5 atmosphere. Wow, that's 1.5 to 7.5. Man, the hydraulics of this thing must be strong. Determine the new volume, okay? If mass and temperature remain constant. So you know for a fact that by reading this question, you're looking at the change of something. Let's lay out everything that is given and what they are asking you to find. So you have before and you have after, okay? Before, you have a volume of 135 milliliter. Now, am I going to change this to liter? You don't have to. You don't have to, and you'll see what I mean by that. And the pressure here is 1.5 atmosphere. What happens after? Well, what happens after is that pressure is now 7.5 atmosphere. And I want to know what is the new volume. So I guess this is V1, P1. This is going to be V2, P2. And I'm looking for V2. Knowing the fact that the mass and the temperature remain constant. Now, when you say mass remain constant, obviously that means mole remain constant. Right? That's not going to be different. It's the same thing. So if you look back in this formula, this could be M1, M2, and there's really no different. Really no different. Yeah, you can even substitute M here, and it'll be the same thing. Okay, because moles is really mass divided by molar mass, and molar mass is always the same for whatever chemical that you're looking at. So yeah, you can easily replace these by M. No big deal. But for this question, you don't need to, because if you think about it, P1V1 over N1T1 is equal to P2V2 over N2T2. Okay? Since mass is the same, mole is the same, so goodbye N. Temperature is the same, goodbye T. So this equation, or this question right here, is really just P1V1 is equal to P2V2. Okay. Now, one of the things that you have to make sure of when you're doing questions like this is that the unit is consistent. Take a look at pressure. Are the units consistent? Do I have one atmosphere and the other one being something else? The answer is no. They're both atmosphere. So thank goodness, because you can just plug those numbers in. Now, I'm not going to change my volume to liters. I'm not. Because I don't really need to. All I have to do is make sure my V2 later on is also in milliliter. I hope you guys already know that. That's not something new. That the volume is going to be 27 liters. Okay. Now, you might want to ask yourself, does this make sense? No. Does it make sense? Obviously, you have an increase in pressure, and now you have a decrease in volume. Well, of course it does, because we saw yesterday with, well, the other class, Boyle's law. Okay, Boyle's law says as you increase the pressure, the volume decreases by looking at the piston and cylinder apparatus. So yeah, it makes perfect sense. So there you go. There you go. That's the volume. Oh, whoa, whoa, whoa. Hey, that's a little bit of a error here. Okay, milliliters. Milliliters. Why? Because this is in milliliters. So it only makes sense that this is in milliliters. Okay. All right. So if you were to change this to liters, I mean, your answer would have been in liters as well. Same thing. All right, so that's the first question. That's a pretty standard question if you ask me. And pretty simple, pretty simple. So let's take a look at another question. Let's do this one. So again, these are questions based on changes. So there's going to be a before and after. So let's take a look at what it says. It says 75 milliliters of hydrogen gas is heated from 27 degrees to 127 degrees. Determine its volume when it's 127 degrees. So this is a Charles law type of question. You remember Charles law, it says that volume and temperature are proportional. Because if you were to heat up a cylinder with, with a piston at a certain place, not applying more pressure or anything, that the molecules will start to move faster and faster. They will bombard each other with more force, creating more energy. In a result, it requires more volume. So that's why when temperature increases, volume increases. So that's what we're going to be expecting. Volume before is 75 milliliters. Okay, volume after is something I want to find out. Temperature initially is 27 degrees Celsius, and temperature finally is 127 degrees Celsius. Now be careful here. Be careful here. You can't work with Celsius. Celsius is useless. You're going to have to change that to my good friend Kelvin. Okay, so 27 degrees Celsius is really just 300 Kelvin. And 127 degrees Celsius, it's 400 Kelvin. Okay? A lot of people tend to forget that, huh? So here we go. Okay, P1V1 over N1T1 is equal to P2V2 over N2 T2. They did say that mass is constant, so therefore goodbye moles. Pressure is also constant, so goodbye P. So for this question, you're really looking at V1 T1 is equal to V2 T2. So there you go. Let's plug those numbers in to find out exactly what V2 is. So you're looking at 75 milliliter over 300K is equal to V2 over 400K. And your final answer should be, let me do this very quickly. As you can see, like last question, I did not change the volume to liters because I'm not going to, because I'm going to keep my final volume to be at milliliter, which I kind of made a mistake of. So yeah, there you go. By increasing the temperature 100 Kelvin, your volume will increase by 25 milliliters to 100. Right? Kind of sick. Okay? So, let's take a look at one more situation, and then I think you guys are good. So let's take a look at this. And then we'll call it for the day, I guess. So 27 grams of carbon dioxide at 50.5 kilopascal occupies a volume of 12.6 liters. If temperature to remain constant, that's nice, at 25 degrees Celsius, what volume of the gas occupies the pressure is increased to 202 kilopascal? All right. Now, the question here is this. They gave you a lot of numbers here, man. They actually gave you a lot of numbers, but not all the numbers are useful. Like, what are they? Well, take a look. Does it look like the mass changed? No. The mass remained constant. So this 27 grams of carbon dioxide gas is really just saying 27 grams. This could have been anything. It really, it's not going to change anything. Okay? What about pressure? Well, yeah, pressure definitely changed. It went from 50.5 to 202. Volume? Yeah, of course. It started out 12.6, and that's actually something I want to know. I want to know what it is. So I'm looking for V2, if you think about it. And temperature remained the same. Okay? So this question is very similar to the first one that we did. So it's just that for this question, they kind of gave you a lot more information than you need. So let's go. So before and after. Okay? So you have initial pressure being 50.5 kilopascal. And the final pressure being 202 kilopascal. Remember, if these guys are not kilopascal, or they're not the same, you need to make them the same. And I've shown you already exactly what the conversion factor was, or the conversion was, I don't know. So, initial volume, 12.6 liters, and final volume is something that I'm interested in knowing. Okay, so it looked like you increased the pressure. So I should expect volume to decrease. We already did this. This is P1V1 equal to P2V2. So let's put that in. 50.5 times 12.6 is equal to 202 times V2. My answer is going to be in liters because I'm keeping volume to be liters, that's for sure. And my final answer, of course, is 3.15 liters. Just as we expected, increase the pressure, decrease the volume. So these are nice questions. These are actually very nice questions. Looking at what happened when things changes. Because this also gives you a better grasp in terms of understanding Boyle's laws and Charles' laws and whatever Avogadro said, and making sure that everybody is looking at Kelvin, good old Kelvin, Lord Kelvin, whoever he is. Anyway, that's it for today. All right? And hey, have a good day.